Okay, so this is part 2. I will continue from question 27. So let's go to question 27. Okay, the question 27 is about lenses. I'm quite surprised that so many of you got it wrong. But it seems that, okay, the mistake is not that bad. You recognize that the image size is diminished. Now, just for the sake of completeness, I will explain from the very beginning and not just focus on the image distance. So just by looking at this question, you need to find out as much information as you can from the problem context. So down here, they give you the object distance, which is 50 cm, and they tell you that it is slightly magnified. Now, what is the implication here? By the word slightly magnified, it means that it is almost the same size. So from your lenses property, if you have an image size that is same as your object size, it will means that your object distance is at 2f. What do I mean? Let me exit this and let me open this. So if you look at this, the focal length is here. So by changing this, you can see that at 2f, the image size and the object size is the same. So this is your lens property. You need to memorize that. So by saying that it is slightly magnified, it means that your focal length is actually, if 2f is 50, then you would have the same image and object size. So now, since the image is slightly magnified, it means that your 2f must be slightly more than 50. Okay, so with that information down here, you can come up with the information that 2f is slightly more than 50 cm. And so now you are moving another 50 cm away, meaning that we take this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 square represent 50. So now it means that I have to move another 10 square, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have to move to here. And you can see that immediately your image becomes smaller, and also it actually goes smaller than 50 cm. Remember our scale here, every 10 square is 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 50 cm from the lens. And you can see that the image now has moved closer to the lens. So of course, you do not have this simulation during exam, but you can always sketch it. So go and sketch the lens diagram if you are not really sure, and you'll be able to see that it is slightly more than 1f from the lens. So from here, 1f is 5 square, so it is slightly more than it. Okay, you can always sketch it and then you'll be able to find it. Okay, so that's how you solve question 27. And let's carry on. This question, I was so amazed that so many of you got it wrong. Okay, the question simply asks you how will the light ray PQ. So your light ray PQ is this, and you can see that the light ray PQ is parallel to your principal axis. So almost the first rule of lens diagram is that if your ray is parallel to the principal axis, after it passes through the lens, it will definitely cut the focal point. Okay, that is the iron rule of the thing. Some of you may say, teacher, but you have told me that when the light intersect, it represents the convergence point. Shouldn't the light ray from here be connected to the convergence point? My answer to you is that, can you see that they are from different light source? If you look at this ray and this ray, they are parallel. Parallel rays implies that they are from the same light source. So if they are from the same light source, after it passes through the lens, okay, then it converges here. But PQ is from another light source. Can you see that these rays are different from these two rays? And so, since they are from different light source, they will converge at different places. Okay? So because of that, you cannot simply assume that, oh, this guy will converge at the same point. You have to follow, firstly, the rules in your lens diagram. Parallel ray with the principal axis will all converge, will all cut through the focal point. Okay, so that's how you get B. Now if I extend the question, or you want to ask further, teacher, so what happens if, okay, let's say from the same light source I have all these parallel rays, where will they converge? Then my answer to you is, what is the rule of drawing lenses diagram? If it is a ray parallel to the principal axis, then they will cut through the focal point. So just cut through the focal point. It will cut through, it will cut through, it will cut through, it will cut through. Okay? So therefore you get your convergence point same as your focal point. And by the way, during your SPA practical, I told you, right, if you take a lens and you try to focus the image on the screen, the distance between the image, the distance between the screen where your sharp image form and the lens represent one focal length. Why? Because when you are just focusing the lens onto your, if you're using the lens, adjust the distance from the lens to the screen, and you got a sharp image, the light coming to your lens is from a far away source, which you can assume it to be parallel ray, which is exactly this case. So therefore, if you have a sharp image on the screen, it will be represented by the convergence here. So therefore, your convergence length and your focal length are the same. Okay? Okay, question 32. I'm still having some difficulty figuring it out. I do not know why is the answer A not accepted. So I will make another video to address this. So your question 38 is actually quite easy to do. By thermistor, you need to know that when your temperature increase, your resistance will decrease. Okay, so with this understanding, when your resistance decrease, it will imply that if you have a small rise in voltage, because now your resistance has dropped, it will enable a much bigger current flow. Okay, and because of that, if you compare this point, let's call this my reference, and if you look at, let's say now I look at this new, you can see that with a small change in voltage, it will give rise to a bigger jump in I compared to this case. So therefore D is your correct answer.